All right. Okay, so inequality symbols. The first one is a less than sign. So for an example, we've got like x is less than 5. So we might verbalize this by saying x is less than 5. The next symbol is less than or equal to. So we could say x is less than or equal to -2. And if we were to draw this on a number line, here's a number line. So -2 would be right here. If we're doing less than or equal to, we would have to fill in the circle. So there's the equal to -2, and then less than would be an arrow going to the left. Greater than, x is greater than 1. So I'm going to do a number line for this one as well. So x is greater than 1, I would put a circle on the 1. I would not fill it in because it's greater than 1, but it doesn't equal 1. And then the arrow would go to the right. And you'll notice for the for drawing the solution on the number line, if your variable is written to the left of the inequality, then the direction of the inequality matches the arrow. So x is less than or equal to, so the arrow goes to the left, the arrow goes to the left, they match. On this one, the arrow goes to the right, the arrow goes to the right, they match. Okay, but you could write that same inequality. You could say -2 is greater than or equal to x. Most people are uncomfortable writing it this way. It feels weird to write it that way, but it's correct. That is mathematically accurate, and now you'll notice that the arrows don't match. So it only works if the variable is written on the left side. Then they match. Okay, greater than or equal to, we'll say x is greater than or equal to 3, and if we write this, x is greater than or equal to 3. Okay. One more thing that we do if we have inequalities that we're solving, so think like you solve an equation, it has an equal sign. If you have an inequality sign, then you're solving an inequality. Anytime you multiply or divide by a negative, you have to flip the inequality symbol. That's one of the special things about solving an inequality, is that anytime you multiply or divide by a negative, you have to flip the symbol, you have to flip the direction of the arrow in between. It doesn't matter if you're adding or subtracting a negative, it only matters if you're multiplying or dividing, okay? All right, so I've got 2 examples for us, and then after that, we have 4 practice problems to make sure we got it, and then we're gonna move on. So first example, I'm going to force us to make sure that we use this idea of flipping the sign. So I'm not going to let us add the forum to the other side, because that would save us from having to do it. I'm going to force us to add the 2m to the left side. I know a lot of us wouldn't have done that, but I'm going to force you to do it. So we have -2m plus 6 is greater than or equal to 14. And then what would you guys do next?
Subtract the 6.
Yeah, subtract the 6. Okay. -2m is greater than or equal to
8.
8. Perfect. Okay. And then what do we do? Divide by negative 2. Okay. Perfect. And so because we divided by a negative, we just have to make sure that when we write the final answer, we flip the symbol. So if we were to now draw our solution on a number line, it would just say, okay, like here's negative 4, negative 3, negative 5, negative 3. So negative 4, it can equal negative 4, so I'm going to fill it in. And then the variable's on the left, so I can go ahead and copy the arrow. Everything less than negative 4. So there's the solution written out. There's the graphical representation or the drawn representation of the solution. Okay. Any issues with that one? That makes sense? Okay. All right, for the next one, what's your first step when you have parentheses in a problem?
Distribute.
Yeah, we have to distribute. So we're going to take the 6, we're going to distribute. So the rest of the problem I can just copy. So when I distribute the 6, what do I get?
6 and 17.
Okay. So I'm not going to do anything to the left side, but what should I do over here? Simplify. Yeah, we're going to simplify. We're going to combine like terms. So I have 6m, and then what else do I have? 17. Perfect. Okay. 3m minus 1. Okay, I'm going to force us to practice this again. So I'm going to say the next step I'm going to make us minus the 6m. Okay. So what do we have on the left side? Okay. It's less than 17. And then what should I do? Okay. So negative 3m is less than 18. Then divide by negative 3. Flip your sign.
Negative 6.
Okay, m is greater than negative 6. So we've got negative 6. We should not fill it in because it can't equal negative 6. Variables on the left, so we can copy the arrow. We're going to go to the right. All the numbers that are greater than negative 6 go to the right. Okay. So go ahead and try the next 4 problems. You don't have to be silent while you do it. You can chat in your groups while you do it. That's fine. So on number 4, what is the very first thing you should do? Distribute. So we're going to take the negative 2. We're going to distribute. Okay, so negative 2 multiplied by n, negative 2n. Negative 2 multiplied by 8, negative 16. Okay, is greater than or equal to negative 16 minus 2n. Now, some people can make the conclusion at this step. They already know. I have a hard time with that. So I'm going to go a little bit further. So what is typically the next goal? Yeah, to get the n's to one side. So I would probably, okay, let me add my 2n. I want to move it to the other side. So I would plus 2n and plus 2n. And so what happens when you do that? The n's cancel out. So if you got down to something and you said that n was greater than or equal to 0 or n equaled 0 or something like that, you were wrong because what just happened? Our n's are gone. Does that make sense? There should be, so either you stopped right here where you had exactly the same thing on both sides, or you got here where your n's were gone. But n is not greater than or equal to 0. N is not 0. Do you see the difference? Okay? So you can have exactly the same thing. You can have this exactly the same thing on both sides, or this exactly the same thing on both sides. Okay? Now, the only way you can have 0 as a part of your answer is if you go a little bit further and you say, okay, let me take care of the 16s. So if I take care of the 16s, I can add 16 to both sides. I get 0 is greater than or equal to 0, but I still don't have any n's in there. Do you guys see that? Okay. Now, what is true about all three of these answers, and all three of these answers are good. We have to interpret these, though. So you could have interpreted the same thing from all three of these, is that you have the same thing on the left side and the same thing on the right side. So on all three of these, the left side and the right side are equal to each other. Now we can't say, oh, every single time the left side and the right side are equal to each other, that's okay, and it means all solutions. It only does for this problem because the symbol said greater than or equal to. Does that make sense? Greater than or equal to. That's true. So if the statement is true, then it's an all solutions answer. So if the variable disappears and the statement is true, your conclusion is all solutions. If the variable disappears and your statement is false, the answer is no solutions. Does that make sense? So I had zeros on both sides. I could have had a 5 over here and a 2 over there. And my answer would have been all solutions. Because 5 is greater than 2. That's a true statement. Does that make sense? Okay. I could have had 1 million and negative pi. And my answer would have been true because 1 million is a very large number. Negative pi is a slightly negative number. That's true. 1 million is bigger than a slightly negative number. But if I had 17 and 18, then I would have had to say false. No solution, because 17 is not bigger than 18. Does that make sense? Okay. So you have to think through what ended up happening with the inequality, if the answer was true or if it was false, and then you can say all solutions or no solutions. So the n's disappeared. Our statement was true, so our conclusion is all solutions. And then since we have to draw the answer, we have to think about what the drawing should look like. So I'm going to draw my number line. 0, 1, 2, 0, negative 1, negative 2. Do I leave it blank like this, or should I draw on it?
Since it's like all solutions, would you do an arrow like going both ways?
Since it's all solutions, you should make the whole thing dark. Everything works. If you just draw a number line and you leave it blank, that's what no solutions would look like. A blank number line is nothing. So for all solutions, we should make the whole thing dark and put arrows on both ends to say, yep, every single number you can think of, they all work. Okay? All right. How are your brains after looking at number 4? That was a weird one. Okay. All right. So whatever you didn't finish on that one, hang on to it. You might be able to finish it this period. You might have to do it for homework. We are not doing a flipped classroom yet, so we still have actual mathy homework for the first couple days. I'm going to go ahead and hand out another page of notes. We're going to do this. This is another type of review, just to make sure that we remember how to do stuff. All right. So next we are solving systems of equations algebraically. Does anyone remember what a system of equations is? We have equations. Those are, things written with equal signs in them. A system of equations. You can kind of tell by looking at your paper. Two equations, yeah. So a system of equations it's two or more equations. Two or more equations. And then the solution is if you were to graph these, if you graph the two equations, or if you had three, if you graph the three equations, or if you had four, if you graph all four of them, the solution is where they cross. It's that single point where the two lines cross. Does that sound familiar? Okay, so the solution is where they cross. And since it's a point where the two lines cross each other, that means that we should always write the answer as x comma y, like in a point, and not just x equals this, y equals this. We should always answer it like a point, okay, because that's what it is. Now, if we're solving them algebraically, that means we're not going to graph them on a calculator to get the answer. We're going to actually do the math by hand to get the answer. So that's what we're reviewing right now. And if you guys remember, I think you learned this in Math 1, but I could be wrong. No, it was not Math 2, it was Math 1. There were two methods that you guys used to solve. One was elimination, and that's where you lined them up and you tried to get one of the letters to cancel. And then the other method was substitution, and that was where you got one of the letters alone and you plugged it into the other equation. So hopefully this is going to kind of jog your memory a little bit. So if we looked at the first example for elimination, I can look at the x's, and if I wanted the x's to cancel out, I should get it so that both of these are 5s. Because if that's a -5 and that's a +5, then the x's would cancel out. Or I could get the y's to cancel out by getting it so this is a +6. Maybe if I could get this one to become a -6, then the y's would cancel out. Everyone see that? So we have two different ways of doing it. We could cancel out the x's, we could cancel out the y's. So what would you guys rather do? X's or y's? Cancel out the x's. Okay, so what we're going to do is we're going to take the bottom line. Since this has to be a 5 for it to cancel, we're going to take the bottom line and we're going to multiply the whole thing by 5. So 5 multiplied by x, 5 multiplied by 6y, 5 multiplied by -28. Okay, so 5x plus, what's 5 times 6y? 30y. And here's when I get my calculator out. -28 times 5, anyone? -140? Yep. Okay. So there's the line that I fixed. Now I'm going to take the other one, I'm going to line it up right underneath. -5x +3y equals -25. And I'm going to draw a line, and I'm just going to add straight down for all of those. Does this ring a bell? You guys remembering this? Okay. So +5x and -5x, they zero out, they're gone. Okay. 30y and 3y, 33y. And then we have 140 negatives and 25 negatives. Okay. And so now, how do we solve for y? Divide. Okay. Oh, I don't know. That's bigger than my head knows how to do. So -165 divided by 33. Yeah, -5. Beautiful. Okay. Okay, I'm not going to put a box around it because that's not my answer. That's part of my answer. So I have to have, my answer has to be x comma y. So if I have the y, does anyone remember how we get the x? Yeah. So we go back to the original. We go back to the original. We pick one of these. It doesn't matter which one. You just pick one of the ones that you like. Now you could plug it into the one that you fixed, but those numbers got big, so I probably don't want to do that. So I'm going to pick one of these. Which one do you guys want? The top line or the bottom? The top one? Okay. So negative 5x plus 3 times the y that I got, and the y that I got was negative 5. So negative 5x plus 3 times the y that I got equals negative 25. How are your brains feeling? Are they having Math 1 flashbacks? Okay. Okay. So now what should we do? Okay, we had a negative 15. We're going to add it. So 25 negatives and 15 positives. 10 negatives. Okay. Okay. Now, I don't put 2 boxes for my answer. I do x comma y, so I do 2 comma negative 5. And let me just grab my cell phone because we love our cell phones. And let me just get on Desmos real quick. So DESMOS, getting on Desmos. And I'm going to graph these. Have you guys used Desmos before? Yes, we should be real in love with Desmos. And so we can see, looking at Desmos, that we have 2 lines that cross, right? And we see, using Desmos, that those 2 lines cross at 2, negative 5. And so what does that tell us about our answer that we just got? That it's right, that we got that answer right. We can feel good about that answer because we did it. Okay. Okay. All right. We're going to go ahead and try this one over here. Okay. Do you guys want to get rid of the x's or do you want to get rid of the y's? X's or y's? X's? Okay. So we can multiply the top line or the bottom line. Bottom, it's going to be easier to make the 2 bigger than it is going to be to make the 10 smaller. Okay, so we're going to multiply the bottom line by something. So how are you going to find a number that could cancel out a negative 10? What would cancel out a negative 10? A positive 10. Okay, a positive 10 would cancel out a negative 10. So how are we going to make this a positive 10? We're going to need a negative 5 there. Okay, so we're going to take a negative 5, we're going to distribute it throughout the whole problem. So positive 10x, positive 5y, negative 5 times 0? 0? Okay. So there's my bottom line, and then I'm going to take the top line. I'm just going to copy it down. It is going to be weird. And then I'm going to draw a line underneath and put a plus. Okay.
Wait, what do you have 0 multiplied
Uh-huh. What's 0 times negative 5? Because 0 times anything is just 0, right? Yeah. Okay. So positive 10 and negative 10 is 0. Positive 5, negative 5, 0. 0 and 1 is 1. Okay, so what we got is the equation 0 equals 1. And this is where we have to think back to what we just did. We just did this on these other notes where we ended up with something where the variable disappeared. So it's happened again. The variable has disappeared. So whenever that happens, we have to look at what we're left with and we have to decide, is it true or is it false? Because that will tell us where to go from there. So we look at this, is it true or is it false? This is false. So when the thing is false, what is our conclusion? No solution. So that means that if I were to graph this on Desmos, what would I see? I'm going to see 2 or more equations. So I'm going to graph this. I'm going to see 2 lines. And the 2 lines are the answers where they cross, but there's no answer. So what does that mean? They're not going to touch, they're parallel. Does that make sense? These are 2 parallel lines. That's why there's no answer. Okay. All right, let's try using substitution. So these are 2 different types of substitution problems. One where the y is isolated in both of the problems. If you know what y equals and you know what y equals, then that means that the 2 equations must equal each other. If y equals one thing and y equals another thing, then they must equal. Does that make sense? Okay. So for this one, I'm just going to say negative 4x minus 13 equals negative 3x minus 9. I'm just going to get rid of the y's. Set the 2 equations equal to each other because they equal the same thing. And that's pretty easy to do because so many of our linear equations are ready to graph. This is like y equals mx plus b form. So many of them are ready to graph already that it's really easy to do this. Okay, so how should we solve this equation? Uh-huh.
So I would just subtract or
Add 3? Okay, so we're going to add 3x. So it was negative, so we're doing the opposite. We're just doing positive. We're doing that to both sides. And then you said add the 13 over. So we're just taking the numbers and moving them to the opposite side of where the x's were. What's negative 9 and positive 13? 4. So negative x equals positive 4. So then positive x equals negative 4. Okay. Well, that's not our final answer because we have to have two lines that cross. We have to have an x coordinate and a y coordinate. So we're going to go back to the original equations. We're going to take that x value, and what are we going to do with it? Plug it in. Which one do you guys want to plug it into? The bottom? Okay. So we're going to say y equals negative 3 times the x value minus 9. What do we get? 3. So we get 12 minus 9 is 3. So x is -4, y is 3. Okay. Okay, let's do this one last example because this one is a little bit more like an actual substitution problem. We're not going to do this example in the middle right here. We're not going to do this one. Okay. So what we have is we have one problem that's in standard form. That's what the form is when the x and the y are together. We have one linear equation in standard form and then one linear equation in the slope-intercept form, y equals mx plus b. So I'm going to go ahead and circle the y right here. That y is not alone. You know, it's got other stuff there. But this y is. So what we're going to do is we're going to take this y. We know that the y equals 5x minus 20. So we're going to take the stuff that we know y equals, we're going to plug it in right here. Because we know what y is, so we can substitute it in. Okay? So what I'm going to do first to make my life a little bit easier is I'm going to start off, I'm going to say negative x minus, and then I'm going to put parentheses for y. So negative x minus y equals -4. So instead of writing the y, I just put parentheses there instead. Negative x minus y equals -4. And then in the place of the y, where I put the parentheses, now I can go back and put 5x minus 20. How do your brains feel about that? Okay. So what should we do to get rid of those parentheses? Yeah, so this negative is kind of like having a -1. And so we can take that -1 and we can multiply it inside those parentheses. So negative x in the front, and then we got -1 times positive 5x. -1 times -20. And then what should we do? Simplify. So we're going to combine like terms. We have a negative x and a negative 5x. So if you have one negative and 5 negatives, 6 negatives. And then what should we do? Okay, subtract the 20 over. So negative 6x equals, okay. Okay, so we know x is 4, but how do we find the y? Yeah. So you can plug it back into either of them, but usually there's one that's a little bit easier. The bottom one, the y is alone on the bottom one, so it's probably easier. So you get y equals 5 times 4 minus 20. So we get 20 minus 20, which is 0. Okay. So if we fill in the blanks at the bottom, the solution to a system of equations is a point and should be in the form xy. Okay. So the thing that you are going to do